Okay, so I would strongly recommend also that because we don't meet very often and we're trying to cover the material of the entire AP course, that whenever you miss a class, you watch the lecture online, because we might get left behind because we're going kind of fast. We're like jumping through topics every day and we're not giving very much room for review or revision. Okay, so the first problem from last time's homework was, so if you remember last class we learned how to evaluate strings. So it was this problem. Does anyone know, did anyone do this problem? Okay, you did? Okay, so basically for those of you who weren't here last class, we talked just a little bit about how when you're given a string and there's concatenations, how it works, like how the final result would be printed out. So can you tell me what was the first step? Okay, good. So because multiplication has precedence, like we talked about. What next? Okay, so
2 plus the string will be the string.
Exactly. So this is an integer, this is a string. Int plus string equals string. So this becomes 2. And then what is this? What will the string look like?
2 space int space 2.0 space.
Right. So even though this is what you learned as casting last time, it's in the form of a string. So it's not going to convert anything that's inside a string into something else. So a string stays just a bunch of characters, and it's not going to try and evaluate those characters. So and what next? So what's it going to look like?
2 space int space 2.0 space 4
Okay.
space 2.
And then, so like that. And then,
2.
and it's just going to add the 2 over there because it goes left to right. So it's not going to add these 2 into 6 and then add it over here. It's first going to add the 4 to the string and then the 2 to the string. So this is something we talked about last class just to make sure that you understood. Then the next one is pretty similar. If you guys have any problems with it, you can tell me around here and move on because it wasn't very difficult. Okay, so you can look at that later for this. Yeah.
What was the answer?
Don't have the answer on this paper, but it will be L 2, 3, 4. No, JK. Yeah. L 2, 3, 4, 3, 0, 7, 1, 7. Is that what you got? Then the next homework problems were. It was from the Barron's book, and it was page 75, problems 1 to 5. So, did anybody look at that? Did anyone get a chance to look at the Barron's problems? Okay, so let's just. Okay, do we have a way of the ladybug thingy so I can project this on this page to them? You don't have that?
No.
Okay. Say that again?
Well, we usually use the 4th edition. Because there's no.
I don't think.
Do you have a PDF of that?
No, I don't. It's okay. Next time I'll take pictures and put it on my computer or something. Okay, so basically, what the problem was, it gave you 3 statements and it asked which one will cause an error message. So I'm going to write this out really entirely. Will this give an error message? Okay, how many of you think it will give an error message? Okay, look at it. Okay, who thinks it will give an error message? Show the hands who thinks it will. Come on, high up, or not at all, no bent elbows. Okay, do we have 3 then? Who thinks it will not? Who has no idea what we are talking about?
Sorry.
Okay, so It's my first time here. Okay, so you don't know what's happening. What about you? Did you know?
What?
Okay. What about you?
I don't know.
Okay. So basically what double is, it's the data type that stores decimals, and int is the data type that stores integers. So what this statement is doing, it's giving the value of a decimal to x. And then it's trying to put that same value of x into y, but y is declared as an integer. So what the statement is trying to do, it's trying to stuff a decimal into an integer, and that's not going to work.
I thought you said it dropped stuff.
So if you try doing this on your computers, just go for it and see what happens. It gives you an error. And the reason, so if you did want to do this, what you could do is you could cast it. Casting is what we talked about before, and casting is basically where you take, so if I did this, I would basically be casting x into an integer, so it converts into an integer, then it tries to put it into an integer. So explicitly casting is always a better option. So this is actually, so number 1 was without the cast, and number 1 gives an error. Number 2 was with the cast. And does this give an error? Who thinks it does give an error? Who thinks it does not give an error? Okay, because I just told you it does not give an error. Yay. So, no error. And then number 3 was int x is equal to 14, double y is equal to x. Who thinks this will give an error? Show of hands if you think that this is going to give an error. Okay, who thinks it will not give an error? Okay, and the reason it's not going to give you an error because you can put an integer into a decimal, right? Like, does that make sense intuitively? Like sticking in this, trying to stuff a decimal into an integer is not going to work. And the reason that it works this way is actually it comes down to the way that the computer stores numbers. And for ints, it allocates a certain amount of slots in its memory. And for doubles, it allocates more slots. So when you try and put a double into an int, you're basically taking something from more slots and trying to put it into less slots. So the computer can't do that. Does that make sense? Like, there's too much memory to put into an integer slot. Okay, so this will not give an error. So the answer was B, for those of you who did it. I don't know. Okay, then the next problem was, what output will be produced by, I'm not writing out the whole print statement. Okay, who knows what this is going to produce? Can anyone volunteer to tell me what's going to be printed by this? Okay, just say it out because not everyone has the book. So, what do you think it's going to be? Just
Asterisk.
okay.
This is not. New line.
Okay.
Of comment. Asterisk.
Okay, and why do you think it's going to print this?
Because
Do you take? Why do you think it's going to print this?
because when you throw one thing, there's the forward slash, and eventually you can find a new line partway through.
Okay, so that's correct. This means new line. What about this? What made you exclude that?
It was supposed to.
Okay, so does anybody else know how you would approach this? Yeah.
You do exactly that, except those slashes, the backslashes will still be there.
Both of them?
Yeah.
Okay, so you say that both the backslashes are going to be there. Okay, who remembers escape sequences from last class? Do you remember escape sequences? What are escape sequences, Tom?
When you have a slash, it escapes the next letter. I mean, the next item there. So the first slash doesn't count, the second one does.
Okay, so basically what an escape sequence is, the slash n is an escape sequence, and what this slash n denotes is that this denotes new line. So that's why when there was a slash n over here, whatever was after that slash n got put onto the next line. So this is one escape sequence. So why it's called an escape sequence is when it sees this first backslash, and is always inside a print statement or a string, it sees this first backslash, it will ignore this letter, but it will also tell it to do something. And in this case, it tells it to go to the next line. This is another escape sequence that we talked about. Does anyone remember what this escape sequence is? Yeah.
Prints a backslash.
How many?
1.
Yeah. So this escape sequence prints one backslash. So the actual answer would have one backslash here and one backslash here, because if you look over here, this is an escape sequence to print one backslash, and then this just prints out. This is an escape sequence for a new line. This prints out. This is an escape sequence for another backslash, which prints over here. So this is the answer, and I believe that was E on the second problem. And okay, I would just try and do the homework, guys, or otherwise there's no way of checking that you've actually understood the material. And I know that we don't have any way of making sure that you do the homework because you're not getting a grade or anything for this class. It's one of the best ways of making sure that you're up to date with the material and you'll be prepared to take the AP test. So, did anyone do number 3?
Wait, what was number 3?
It was...
Is it like IKK?
No.
Oh, no, from that one.
Yeah, number 3 from the Banner book. So basically what number 3 was, so a programmer puts this in. Double answer is equals to 13 over 5. And they print, not writing the full print statement, 13 equals plus answer. What is going to print from this? Can anyone tell me? So this is a string because it's enclosed in double quotes, right? So it's going to print exactly that. So 13 divided by 5 equals. And then this is a concatenation, right? So it adds whatever's after this. Does anyone remember what the value of answer is? Int divided by int. Yeah.
Another integer.
Yes. So what is the integer?
3?
Yes. Okay. So because of this. Right. Yeah. Okay. So 13 divided by 5. What would that actually be? It would be 2.6, right? But since both of these are integers, and like we talked about last class, and a mathematical operation with 2 integers will give you not a double, an int. And if you want it to give you a double, at least one of them has to be a double. So over here, what is this going to evaluate to? Like Praveen said, it's going to evaluate to 2. So the question was, given the following code fragment, the output is 13 divided by 5 equals 2. And the programmer intends for it to be 2.6. So what could you do to this code to change it and give that result? Yeah?
Make it 13.0.
Okay, you could do that. What's another way of doing it? Yeah?
You can cache one of them as a double.
Exactly. So you can cast one of them as a double. So over here you would put double 13, or you could put double 5, or you could do both. So then that would basically convert this result to 2.6, and then that's what it would print. And if I hadn't done this, what would have printed? It would have printed 2.0, because remember that this is of type double, and even if the double is a whole number, it's going to add the 0.0 at the end. talk to one of us after, but we're going to move on because we don't have very long. Okay, so then we have another problem up for the homework. This is not as hard, like rules-wise, but it's harder to track. So we'll talk about this. Int k. Okay, so they've given you this bunch of code, and now they're asking you at the end of the program, what are going to be the values of x, I, j, and k. So over here you can see initially they declare a bunch of constants for I, j, and k, and then they use those constants to come up with an answer for x. And then after that, they alter the values of I, j, and k one by one in separate statements. So this one isn't a very complicated problem, but they might give you a more complicated one, and with this it's easy to forget what the current value of that variable is. So what I'm saying is now over here you've redefined I, so it's no longer 2, right? So the value of I after this statement is executed is going to be something different. And if you use this value of I, when you're using I to calculate k in this last step, you have to remember to use the current value of I, not the old value of I. So a good way of making sure that you're doing this kind of problem right is you set up little boxes for each variable, and you go line by line, and you evaluate each variable. So int I equals 2, what do I do?
Write it in the
Exactly. So same with j and k. Now x is equal to I plus j plus k. So this would be 9. And now I is equal to x. So you look in the x box. X minus I minus j. So 9 minus 2 minus 3, 4. Right? Does that make sense? You follow the boxes. And then, so you would replace the value of I, because I has now been redefined. So I now is 4. And then, same for j. So j would now be x. You take x minus current value of j minus current value of k. So that's going to be 2. And then replace j over there with 2. And now for k. So k is going to be x minus I, which we just defined as 4 over there, minus k, which is defined as 4. So if you notice over here, if we hadn't been using these boxes, a lot of people might have, in this step for I, confused the value for 2, and it would have gotten messed up. So now you know that the value for k, new value is 1. So then, these are your values at the end of it. And this one wasn't that difficult, but if you get a more complicated problem, this is just a good way of tracking the values of the variables. So yeah, I just showed you that to show you a good way of approaching the problem. Okay. So if you remember that we did a problem from last class, which was adding up, finding the average of 10 scores. Now I'm going to be behind you and talking from behind you, but just watch my computer screen. Okay, so if you remember, this is the program we wrote, and we defined 10 values for scores. Can everyone see that? Okay, so we defined 10 doubles, which are holding scores, and then we wanted, the point of the program was to calculate and print out the average. So how we did this was we added up all the 10 scores, and we stored it in a variable sum, and then we divided sum by 10. Simple calculation. So now I'm going to introduce the concept of a shorthand. So another way of doing this, of calculating sum, would be I could start out by declaring sum as 0. And then one by one, I could add values to sum. So I could say sum is now equal to the previous value of sum plus score 1, right? Does that make sense? And then to do the next one, I would do sum is now equal to the new value of sum plus score 2. So if you see over here, if I had to do this for all of these steps, it would basically be repeating all of this and just replacing score 2 with score 3. So in these statements, it's kind of redundant because you say sum twice. And in programming, there's going to be a lot of instances in which you're adding a value to a variable that already existed. So it's going to be like you have int I, and you want to keep adding 1 to I. So then you would have to do I is equal to I plus 1, stuff like that. So it just gets a little redundant. So a good way of approaching this is what they call shorthands. And it's a feature that is built into Java. So the shorthand notation for doing this would be I plus is equal to whatever I want to add to 1. So, hope you can see that. But basically another way of writing I is equal to I plus 1 would be I plus is equal to 1. So I am adding 1 to I. And this would work with anything. This could work with another variable x. This could work with an entire long statement of operations. So, and this also, it doesn't just work with plus, but it'll work with minus, it'll work with division, it'll work with multiplication, it will also work with the modulus that we talked about last time. So, like we said, that this is the assignment operator. These are all also operators.
Yeah, so that it's a feature built into Java, but can we write that on the test?
Yes. So it's a lot of the problems that you'll get on the test will actually use this kind of shorthand notation, so you have to know how to read it. It's just a convenience that is built into the language. So, another way of doing this whole sum equals sum plus score 2 thing is here. Like that. So sum plus, and then we keep adding score 1, score 2, score 3, score 4. So I mean, this doesn't, I'm just using this example to show you how it works. This isn't necessarily less statements, but this is a way of doing it. And then, now over here, what we've done is we've just straight out printed the average. So when I run this program,
So does it only work with the plus sign, or does it work with like other operators?
so like I said before, it works with so it'll work with negative, it'll work with minus, it'll work with division, it'll work with multiplication, and with modulus. Yeah, no worries. But yeah, so it works with all arithmetic operators, and you don't have to just add a constant on this side. Like I said, you can add a sequence of an entire expression, or you can add a variable. Yeah. And then over here, so the program currently, all it does is it prints out the average. So let's try and print it in a way that's more appealing to say. So how would you print it in a way that's more appealing? So it would display all of the numbers, and it would say this is the first score, this is the second score, and then after that it would print the average saying this is the average. Can someone tell me how you would do that? Yeah.
You just have a screen that says, you could append every score, like you just say your score is, and then
Okay.
your
So you
average.
could have some kind of statement that says score 1, and then you could concatenate it with score 1, and then you could so then that would show up as score 1 is equal to 100. So if you did this for all of it, it would look somewhat like that. So just kind of get used to the idea of making things so that you know what the program is doing and so that it doesn't just throw a random number at you. So if you look at the output right now, at the top it'll say class scores, then score 1 is equal to 100, score 2 is, and then all the way, and then average score is equal to that. Now, another way to just make it look nicer is to use the tab escape sequence that we talked about last time. So it's just the slash with T. So you could do over here, if you put a tab in at every line, it puts in a tab before every score, so it kind of aligns it up so it looks more presentable that way. So just take advantage of all the escape sequences, the features built into the language. Okay, now we talked about, can I turn it off?
It's your job, you have to do it in front. It's not really happening. And then one more.
Okay, it's not working. I'm just gonna write it over here. So we talked about binary operators, which are basically operators that operate on two things. Can someone give me examples of binary operators? So plus is a binary operator because it's operating on this variable and this variable. So it's operating on two things. What are some other examples of binary operators we went over? Minus. Yeah. Right?
Modulus.
Okay, so there are also, these are all binary operators. There are also what are called unary operators. From the name, what do you think a unary operator does? Exactly. So there's two kinds of unary operators in Java, which is the increment operator and the decrement operator. And what these two operators are is if I have int I is equal to 1, and I want to increase the value of 1 by 1. Okay, let's just make it 2 so that I don't have this down here. If I want to increase the value of I by 1, so then I will be incrementing it. Incrementing means adding 1, and decrement means subtracting 1. So what I could do over here is a simple statement, I plus plus. And what this does is I's value is now 3. And then I minus minus removes 1, so it's back to 2. So it's really simple. It's going to show up on the AP test, so you should know about it. Any questions about that? Okay, so this is what is called, if you look over here, I put the unary operator after the variable. So this is post increment and post decrement. You can also do it this way. So plus plus I and minus minus I. Does anyone know what the difference between these two is? Okay, so what it does is basically at this statement now, the value of I is actually still 2. But by the next statement, it makes it 3. So what post increment and post-decrement do is that it will perform the operation after you use the variable in this statement, and then for the next statement, the plus or the minus will have been performed. So why you need to care about this is, for example, if you did system out.print, and you did I plus plus, and the value of I was currently set to 2, what would it print? Yeah.
3.
It would not print 3. So that's what I'm trying to say. So when it uses it in this instance, it uses the old value, but then if in the next statement, I went and I said system out print I, over here it would print 3. Because by the end of the statement, it's changed the value from 2 to 3. But in this statement, because it's a post-decrement, the value is still 2. But now if I change this to pre-increment, sorry, did I say decrement? I meant increment. Increment is for pluses, decrement is for minuses. Post is when it's after the variable, pre is when it's before the variable. So if over here I change it to plus I, what would this statement print? Yeah. Exactly, because it performs the operation on the variable before it uses it. And then this would also print 3. So the output here would be 3 and 3. But now, if I change this to I plus plus, it would print 2 and 3, because it maintains the previous value before it performs the operation. And then for the next line, the new value is established. Does that make sense? Does anyone have any questions? And it works the same way with the decrement, so the minuses. So I minus minus in this case would print, in this statement it would still be 2, and then this statement it would be 1. But if I did pre, then in this statement it would be 1, and it would be 1 over here. So that's just unary operators. That's the only kind of unary operator you'll be dealing with. Plus, plus, and minus, minus. And who remembers when we did operator precedence? So what was the precedence table? Which operators did we do first? We actually, its modulus is at the same level of precedence as some other operators also. You actually do parentheses first, and then
It's multiplication division.
yeah. Multiplication, division, and modulus are at the same level of precedence, which basically means that if there's a bunch of these one after the other, it would just go left to right. And then what's the next level of precedence? Yeah. So unary operators fit in over here. So you would still always do brackets first, but unary operators take precedence over all the multiplicative operators. Okay, so does anyone have any questions about precedence, unary operators, binary operators? Anything? Okay.
What does modulus do?
Okay, so we talked about,
No, what does modulus do?
yeah, we did it last time. But basically what modulus is, it's remainder.
Okay, got it. Okay.
Yeah. We did a couple of problems with it last time. Okay, now, I feel like this problem, a lot of people, it's on last night's homework, it's related. A lot of people might not have gotten it. Did anyone figure out if I have a variable int x and I give it some value, how do I write a program that will print 5? Because 5 is the last digit. And if I change it to 30, it should print 0. If I change it to 272, it should print 2. Did anyone figure out how to do this? Does anyone know how to do this? Okay, do you think if I gave you like 5 minutes, you would be able to come up with a solution? Okay, how about you just think about it for a little bit. We'll come back to it at the end of the class. It's actually a very easy problem. We'll come back to it at the end of class. Think about it for a little bit. Okay. You got it? Okay, you think you got it? Or you know you got it?
Let me try it out.
Yeah, put a bunch of values in for your variable and see if you get the right result. Okay, so now we're going to try and write a program to calculate circumference of, to calculate the area and circumference of circles.
Yeah, I think you're good. Okay. I think we'll come on. It's like maybe, I don't know, 15 seconds.
So everybody create a new class and call it circle calculations. Oh, there. So just right click your folder, say new class, and you can call it circle. Okay, so same as the same. Okay, can somebody tell me what I would put here to start the program? We talked about this, I think this was first class. Does anybody else remember? Anisha.
Public, static,
Okay.
void, main, string, args.
And just string args?
Yeah, we have to put parentheses,
Yeah.
and then args. Yeah, args. Awesome. And then the opening.
Great. Okay, so that's my main method, and like we've talked about before, that's what the computer is going to jump to when you run the program initially. Okay, now let's create an integer to store the radius. So int r. Let's just call it int r. Give me a random value, someone.
12.
12. Okay, so the radius of the circle is 12. Now, what is a value that you're going to need to do any calculations with circles? Pi. Okay, so I can declare double pi. And what do I want that to be equal to?
3.141592.
Yeah, I'm just going to 3.11, please. And now I can do, so let's go ahead and call area is equal to, how would I calculate area?
Pi squared.
How would I put that into a computer? Okay.
The weird.
You actually,
No.
no, that's not what I'm, it's very simple. We've used it before. Yeah,
Just do pi times r times r.
exactly. You just do pi times r times r.
Isn't there a thing with math?
Yeah, so I'm going to talk about that. This is my segue into that. So I could calculate the area like that, and I could print area. And now, okay, this will give me the right answer. But now, what if some evil person went into my program and they redefined pi as just like 3? I would get the wrong answer, and that's not cool. Or they could even do 10. That would like throw me off so much, and that's just not awesome. So, a way you can prevent this, if you know that there's a program in your number, a number in your program that you do not ever want to change, like it's some kind of constant, like for example, it could be the size of a box that you want to draw, or something that you know you're not going to change and you don't want the program to be able to change it later. There's a keyword that you can put in before you declare that variable, and it's called final. So by sticking, if you look over here, I just put in the word final before I declare double pi, and by putting in that final word, every time after that somebody tries to redefine pi, they're going to get an error. Because pi is final. So then one click fix available, remove the final modifier of pi. So that's just going to give you a syntax error and your program won't compile. Yeah. Well, they can, but the point of this is not that someone's going to, the example I'm giving you right now is that someone's going to get into your code, but eventually you'll be writing programs that are so long that there is a danger that you yourself will put in a line of code that will mess up a variable you don't want to mess up. Does that make sense? And then because you have declared it as final, your compiler is going to tell you, wait, you didn't want that variable's value to change. So final is a good way of preempting that. Now, does anyone have any questions about final? Okay, so it's just a good tip to know. Now, Anusha mentioned before something about this math stuff. So there is a feature of the Java language, and it is what is called the math class. So it's kind of You don't need to understand how this is integrated into the language, but just consider it a feature of Java. And the math class has a bunch of functions built into it. So it has a constant that is math. This n is always capital, dot pi, pi capital. And this is, the value of this is set to like really, really close to the value of pi, whatever it is. So it's just handy. So over here, instead of saying double pi is equal to 3.14, I could completely eliminate that step, and over here, I could put math.pi. And then it would pull the value of pi that is stored in this math fancy magical location that you don't need to understand too much right now. And it would put that 3.14 over there. So
Math.pi or math.pm?
say that again?
Math.pi or math.pm?
PI. Yeah. Capital P, capital I. And then also for those of you who have, I think this comes up in algebra too, but E is also a mathematical value, so the math class has E stored in it as well.
Math.e.
Yeah, it would just be math.e. So these are the constants that are in the math class. And there are some methods. Now, you guys will learn how to write your own methods later in this class, but the math class also has methods. So, and Michelle mentioned before, do you know about some of the methods in the math class?
There's square root.
Yes. There's square root. There's square. So, I have a list of the ones you guys need to know. So for the APCS test, you guys don't need to know very many of these. You need to know about math.pi. You don't need to know about math.e, I just told you. There is math.abs. Does anyone know what that might be? Yeah.
Absolute value.
Exactly. So how you would use this is you could say math.abs, and then in parentheses you would put, say, x, and it would give you the absolute value of x. So you could put this into some calculation, or declare like int m is equal to math.absolute of x. So this is what is called a method, like giving some value to it, and it does some calculation on that value, and it gives it back to you. So you need to know math.abs. You need to know math.pow. Can anyone guess what POW is? Yeah, I heard you say it. Yeah, it's power. So what it is, and then over here, you would put the base, and then you would put the exponent. So, can anyone tell me how I calculate 2 raised to 3? Yeah.
Math.pow and then parentheses 2, 3.
Yes. So 2, 3, and math.pow. How? Wow, I never thought of it like that. How? Okay. And then the last one you need to know is math.sqrt. I'm sure I mentioned this one before, and it's just square root. So, or whatever you want to do. Now, let's try and actually put this into the program that we were writing. So I could just take out this entire line declaring the value of pi, and over here, and if you looked, the instant I took that out, it gave me an error because pi doesn't exist anymore. So that's just a simple syntax error again. Math.pi multiplied by r multiplied by r. So, does that work for everyone? Try and put it in and see if it works. Does it work for everyone? Yeah.
Wait, is math a class?
Yes, math is
Wait, why don't you put it? Yeah.
I'm surprised it's not giving me an error right now. I was going to explain the importance to you guys using this, but it's giving me an error. But anyway, so basically right now, math is a class defined in some Java library somewhere. So Java has a bunch of libraries that you can use to do some. So for example, if you wanted to find the absolute value, there is a way of writing a method to do this yourself. You will be able to write a method to do this yourself later on in the class, but it's kind of wants to use the value of pi. Everyone wants to be able to calculate absolute values. So it's a library, it's in the Java library somewhere. And whenever you use methods and classes that are built into the Java library, you have to import them. So I don't think you ever see this on the AP test, but you're pretty much, whenever you get into writing big programs, you're going to be using import statements. And so you would say, at the very top of your program, you would say, all lowercase import java dot lang and then dot star. So this is basically saying go into the Java lang folder and import everything over there. The star is basically indicating that import all the classes and functions in the Java lang. So now it's telling me that you don't use this. I have a feeling it's because the math classes are built into Eclipse, so it doesn't require the import statement, but you should know that sometimes if you're using an environment other than Eclipse, you'll need to put that there. But right now it doesn't require it. I think it's because math is built into Eclipse. So yeah, that's package imports. Now, let's try double mess. Is going to be math.square root of -5. Let's see what happens. Okay, so, and I'm going to try and print mess. What, did you guys get something? Yeah, so, yeah, so this is what is called a runtime error. So in the output of your program, it's going to indicate that something went wrong and it couldn't do it.
So
Yeah?
what if I wanted like a complex number? So what if I wanted like?
Then you would have to use different classes and libraries. So this math library doesn't support complex numbers, so you just have to find one that does. Yeah?
So if I just put like import all of that, then we do it.
So the thing is that then you would have to change, you wouldn't be able to use the math class. There might be, I honestly don't know what classes you would have to use, but you would have to look it up yourself and find the Java library that contains the functions and the methods that are able to do that. Does that make sense? Because there's like a bunch of libraries out there created, honestly, like, we could create our own imports and then, we could create our own packages and upload them to the web and someone could download it and import it into their program to use it. So at some point of time, you could write a bunch of functions that do some calculations that you want. So you would just have to find the packages and the imports that would allow you to do that. So the math class in specific, which is the one you're going to be using for the test, does not have that functionality. Does that make sense? Any questions on math? Yeah?
So does it give you the error when you attempt to do the best square root or -5 or when you print it?
So it would, the thing is that it's, so we talked about the 3 types of errors before. Does anyone remember what's the 3 types of errors? Yeah.
Runtime, logical, and syntax.
Okay, so syntax is the red ones that pop up while you're writing the code. And then runtime is something like what we just showed, where it runs the program, like the compiler, Eclipse does not complain, and it runs it, but then in your output you see that something's wrong. And then logical is when your program runs and it gives you an output, but it does something wrong. So it could be like, instead of adding 2 things, you subtract them. That's a logical error. How about you try it, see what happens? Yeah. Good. Thank you for working. How about you guys try something, another mess? Double mess 2. Do 5 divided by 0. See what happens.
Exception.
Yes, so this is another runtime error. So it gives you a big red exception and red main, arithmetic exceptions. So later on you're going to learn about some common exceptions and you'll be required to know those for the AP exam, and arithmetic exception is one of them. Arithmetic exceptions are when you divide something by 0. So that's another runtime error, an exception. Now what happens if I don't print mess? So it's not going to give you an error immediately, but what's going to happen is, oh, I have to take out my 0. It's not going to give you an error, but then, yes, it's not going to give you an error, but what's going to happen is that in the memory space that you dedicated to mess, in which you try to calculate the square root, it's going to have that.
Not a number. NaN is not.
Yeah, so NaN, so it's going to have NaN stored. So because you didn't try and print it, your output was not like messed up. But if you tried to use the value of that variable again, you would come up with an error. Let's try that. So I do double mess 3 is equal to mess plus 1. And now let's print mess 3. So it gives you an error. Yeah, so it will give you NaN. So then all calculations you try and do with that variable are going to give you not a number. Okay, does anyone have any questions on what we did today? The math class, unary operators. If nobody has any questions, we'll talk about the last digit problem. Okay, so for the last digit problem, Priyanka, do you want to tell us how to do it? Come up here. Can you show everyone? So it's using just one math operator that we talked about last time. Last digit. That's not how I was. That's one way of doing it. So we did X. Wait, how did that? Can you explain the logic behind this? This is not how. Okay, now do you want to take a look at this? Such an interesting solution. Okay.
It's pretty much what calculus is.
Well, yeah. I've never thought about this. Okay. Do you want to look?
You can see them.
So it's smart. Do you want to? Okay, you can sit down. Thank you. So what she did. It's actually pretty clever. You could have just honestly, so what I was going through was X modulus 10. So what it would do is it would divide 25 by 10, and it would just give you the remainder, which is always the units place of a number. So that's how when someone asks you to get them the last digit, or someone asks you to, well, you'll learn later using some other features also how to break down a number. So someone would say, give me the third digit of this number, or add together all the digits of this number. You'll be using the modulus operator in that case. So if you take the remainder of any number divided by 10, you're always going to get the last digit of it, unless we're not talking about this. But basically what she did, so can anyone tell me why this worked? So what is x multiplied by 10?